Hello, this is Chu Yin. Today, me and my teammates are presenting the Antique Bidding System, ABS. The Antique Bidding System is a web-based and mobile-based platform that allows users to buy or sell antique items through an online bidding system. This system emphasizes transparency and secure transaction. The sellers can list their items and buyers are able to place bid within the allocated period, and the highest bid will win. So this is a brief description of our system. So the audience and stakeholders for this system, the first one is the primary target audience. We have collectors and buyers where they seeking for the authenticated antiques with secure, transparent bidding mechanism. And then the sellers and dealers, they can create and manage auction listings, and they can upload item description, images, and starting prices. For administrator, they can manage users' auctions and monitor system performance and transactions. So we have the external stakeholders. Because ABS relies on automated integration with external downstream and upstream nodes. So the first is identity and KYC APIs. KYC also known as Know Your Customer. This external identity will verify the user's identity and credit status before they place bid. The next one is payment gateway. So this API will process secure and final financial transaction. Next is NTP server. NTP, also known as Network Time Protocol servers. Our system will rely on this server to ensure the internal time is perfectly synchronized. Lastly, we have the historical provenance registries. So the ABS will cross-reference to museums to ensure that the antique is not a stolen item or counterfeit. So this is the core system functions. Our system have mainly three parts. First is identity and know your customer. So this one we need to verify the user's identity and credit status before they place the bid. And we have the live auction engine. This live auction engine is perfectly synchronized via NTP servers, maintaining absolute clock accuracy across global participants. Lastly, we have the secure settlement. So this integrated payment gateway operating under FIPS 140-3 cryptographic modules to ensure that the transaction is secure.
This is the context diagram for our antique bidding system. There are few human actors and external digital service for our system. And for the inbound data, we have sellers input precise item descriptions, buyers submit real-time bids, and final payment authorization. For outbound data, the system dispatch transaction requests to payment gateways and triggers the automate alerts via the notification engine. And for the governance, administrators hold override capabilities to manage disputes, flex user, and oversee the ecosystem integrity. And for data flow diagram level 0, this is our data flow diagram level 0, and it breaks down the central system into five primary sub-process, which mapping the exact trajectory of user data into internal data stores. So the first process is manage accounts and verification. It handles registration, pushing validated profiles and directly to the user data store D1. And for process 2, manage listing and auctions, it cross-reference and take metadata with provenance registry before writing to the active auction database. For the third process real-time bidding, the high-frequency call that reads current bids, evaluates limits, and write validated updates to the bidding ledger. For the fourth process, execute payments, it finalizes the cycle by locking the ledger and securely interfacing with external payment process. And we have the final process generate system operation, which mainly operate by the administrator to have system overview and do comment and dispute flags. For the data flow diagram level 1, we have the first sub process is eligibility check. The system first verifies the buyer's identity and standing against the user data store. And second, consult the NTP server tick against the auction exact target cross time. Expire auction instantly reject traffic. For the third sub-process, threshold validation compares the incoming bid amount against the current highest encrypt record in the bidding ledger. For the fourth sub-process, commitment, only bids successfully passing all prior gates are encrypted and commit as the new highest value. This is one of our main data flow diagram for level 1.
Okay, I'm Chan. The next one is quality, assurance, and testing. We got 5 type of testing type. Okay, the first one is functional. We test the system operates exactly according to the business logic. The second one is integration. So we check the communication and data flow between the ABS and third-party service. The next one is security. So we need to protect the sensitive user data, such as the password or the username, against the malicious. The fourth one is performance. So we need to test the platform speed, the stability, response under high traffic, okay, the usability. So we need to make sure the system is usable across device. The next one is project execution plan. So this is our plan for this project. It have 10 weeks for this project. So the main part is initialization and agriculture and design, development, deployment. So we got 2 types of deployment. The first one is more on the valuation. deployment template. The last part is the cost estimation breakdown. We use COCOMO model for this project to calculate the person. So we need 27 person per month. So the cost for 27 person is 6,000 per person. So 27 multiplied by 6,000 is 162,000. Okay. The additional cost is the service or the subscription for the service that we needed. So the cost is 32,000, which is our estimate cost. So the total is 194,500. That's all. Thank you.